Ever taken a stroll along the shores of the Great Lakes? It's the sparkling water, the vast horizon. It's a breathtaking sight. But beneath that beautiful surface, a silent invasion has been unfolding for decades, with devastating consequences. Today, we're diving deep into the story of two tiny mollusks with a massive impact: the zebra and Quagga mussels. These invaders are native to the Caspian and Black Seas region in Eastern Europe. So how did they travel halfway across the world to North America? The answer lies in global shipping. In the late 1980s, these mussels hitched a ride in the ballast water of large ocean-faring ships. When that water was discharged into the Great Lakes, the mussels were released into a new, ideal environment, with plenty of food and no natural predators. It was the perfect storm for a biological invasion. They first appeared in Lake St. Clair in 1988, and from there, their spread was astonishingly fast. Within just a few years, they had colonized all 5 Great Lakes. So, what makes them such successful invaders? It's all about their reproductive strategy. A single female zebra mussel can release up to 1 million eggs in a single spawning season. Their free-swimming larvae, called villagers, can drift on currents for weeks, traveling huge distances before they settle and attach to any hard surface they can find. And when I say any hard surface, I mean any hard surface. Rocks, boat hulls, docks, and even other native mussels. This is where the problems begin. Imagine millions of these tiny, sharp-shelled creatures blanketing every available inch of the lake bed. This is the reality in many parts of the Great Lakes. One of the most visible impacts is on the water itself. Before the mussels arrived, the Great Lakes had a certain level of natural cloudiness from suspended algae and sediment. But zebra and Quagga mussels are incredibly efficient filter feeders. Each one can filter about 1 liter of water per day. Now multiply that by trillions. The result: dramatic and seemingly positive increase in water clarity. The water looks cleaner, clearer, more pristine. You can see straight to the bottom in places where you couldn't before. But this isn't a good thing. That clearness is a sign of a starved ecosystem. The mussels are filtering out the phytoplankton, the microscopic algae that form the very base of the aquatic food web. Think of phytoplankton as the grass of the Great Lakes. It's the primary food source for zooplankton, which are then eaten by small fish, which are then eaten by larger fish, and so on. By hoarding this essential food source for themselves, the mussels are effectively pulling the rug out from under the entire ecosystem. Populations of native microscopic organisms have plummeted. This has a ripple effect up the food chain. For example, Dipareia, a tiny, shrimp-like crustacean that was once a critical food source for many fish species, has virtually disappeared from the lower Great Lakes, where the mussels are most dense. This has led to declines in the populations of the fish that depend on them, like whitefish and sculpin. The changes don't stop there. The clearer water allows sunlight to penetrate much deeper than before. This has caused an explosion of aquatic plants and filamentous algae, like cladophora, in the nearshore zones. These massive algae mats can wash up on beaches, where they rot and create a foul-smelling, unpleasant mess, impacting tourism and property values. Even more disturbingly, these rotting algae mats create a low-oxygen environment that is perfect for the growth of certain types of bacteria, including those that produce botulism toxins. When birds like loons and gulls eat fish that have been exposed to these toxins, it can lead to massive bird die-offs. It's a tragic, indirect consequence of the mussels' presence. The mussels also fundamentally re-engineer the physical environment. They attach themselves to native freshwater mussels, sometimes in such large numbers that the native mussels can't open their shells to feed or breathe. They essentially smother them. This has been catastrophic for our native mussel species, many of which are now endangered or have been completely wiped out from areas of the lakes. Beyond the ecological devastation, zebra and Quagga mussels have a staggering economic impact. Our modern lives depend on water, and we pull a lot of it from the Great Lakes for cities and industries. The mussels love to colonize the inside of water intake pipes. They build up in thick layers, clogging the pipes that supply water for drinking, for cooling power plants, and for industrial processes. Imagine a pipe that's several feet wide being reduced to a tiny opening just a few inches across. This severely restricts water flow, forcing facilities to spend millions upon millions of dollars every year to control them. This involves scraping the pipes, flushing them with hot water, or using chemical treatments like chlorine, all of which come with their own costs and environmental concerns. These costs are ultimately passed on to all of us through higher water and electricity bills. The U.S. Fish and Wildlife Service has estimated the economic toll of these mussels on the Great Lakes region to be in the billions of dollars since their arrival. So what are we doing about it? Unfortunately, once they're established in a massive body of water like the Great Lakes, eradicating them is practically impossible. The focus has shifted from eradication to control, and most importantly, prevention of their spread to new water bodies. There are massive public awareness campaigns across North America. You've probably seen the signs at boat launches. Clean, drain, dry. This simple mantra is our best defense. Boaters are urged to meticulously inspect their boats, trailers, and equipment for any attached mussels. They need to drain all water from their bilge, live wells, and motors, and let everything dry completely for several days before moving to a different lake or river. The microscopic villagers can survive in just a few drops of water, so this step is absolutely critical. Scientists are also researching other potential control methods. These include developing targeted biocides that kill the mussels without harming other aquatic life, exploring genetic modification techniques, and even using natural predators from their home range. However, each of these comes with its own set of challenges and potential risks. Introducing another non-native species to control an existing one, for example, has a long history of backfiring spectacularly. The story of the zebra and quagga mussels is a powerful and sobering lesson. It shows how a seemingly small organism, introduced to the right place at the wrong time, can trigger a cascade of changes that unravel an entire ecosystem and cost us billions. It's a stark reminder of the interconnectedness of our world and the profound responsibility we have to protect our natural environments from invasive species. The Great Lakes will likely never be the same as they were before the 1980s. But by understanding the threat and taking action, we can work to protect what's left and prevent similar invasions from happening in the future. Thank you so much for watching. If you found this video informative, please give it a thumbs up and consider subscribing for more deep dives into our natural world. And let us know in the comments if you've ever seen these mussels yourself. Stay curious, and we'll see you in the next one.